just completed the qualification for Aeon R Stage 1 engine. And what that means is that we've put that engine now through the paces that it will see in a flight-like condition throughout the operation ranges that we expect that engine to see in flight. And we validated the functionality of the engine, the systems as they are designed. We've confirmed that the performance is adequate for our flight, and we validated the life of the engine will meet the operational expectation of the engine.
We run long duration tests, we run lots of different operating conditions, and we do this to find any gaps that we need to change for the flight production engines and to buy down risk for flight.
So with qualification being the general screen for the flight operating conditions, some of the things we want to see can be broken into a couple categories, being run boxes, start boxes, and gas interface conditions. So with the run box, you can imagine a box like this, where engine chamber pressure, or PC, is on the x-axis, and engine mixture ratio, or ox to fuel ratio, is on the y-axis. You can paint a box of what we want the flight engine to be able to safely operate in. And what we'll do is actually go test at each one of these corners and fill out the entire thing.
Start box testing is where you are proving that the engine can reliably start at different temperature and pressure conditions of the LOX and liquid natural gas that is going into the engine.
Last of all, the gas interfaces. So things like purges, igniter commodities, engine pneumatics. We want to see that the engine operates well at all those conditions too.
The risk tolerance is a little bit different than dev because we are willing to damage some hardware a little bit more during dev in order to learn faster about the engine. During qual, we still want to learn fast and we still want to stress the engine, but it's very important that all of the major components stay as static as possible through the qual test campaign so they get that life accumulation.
Unlike other milestones where you can get lucky, say a mission duty cycle milestone that we should all be proud of from 2023, that was one hot fire of a mission duty cycle, ascent duration burn. You can get lucky once and accomplish that, but in the qual, you need to do over 60 tests and they all need to work. So that means you need to get lucky 60 times. And at that point, it's not luck anymore. It's a good design and it's a good team.
You always end up leaving qual with issues that need to be addressed. The important part is identifying with confidence that the engine, as you have it designed, can meet the intent of flight.
We've taken a very iterative approach to Aeon R design and development. The first block of the engine was designed to be the first draft. We wanted to manufacture it, see what was hard about manufacturing it, and test the components as individual pieces. On block 2, we took the learnings from manufacturing and component tests and made our first integrated assembly that we tested as an integrated system.
A developmental engine is basically just validating and figuring out what works on an engine. You then take those assumptions and then make changes to the engine and then make it flight-like, which means all of the components, a flight-like avionics system, flight-like instrumentation suite. And from there, you're validating that the qual engine matches your intent.
And then on block 4, we really narrowed in on the flight design. So we were able to learn from those previous iterations of the engine to get to what we needed for a qualification and flight design. There are a lot of things that are hard about designing a rocket engine. One is engine packaging. The shape of the engine controls how many engines you get to place on the vehicle. Another challenge is extreme thermal differences in close proximity. So inches apart, we have components that are about 1700 degrees Fahrenheit apart in temperature, which is challenging from a design's perspective. Another design challenge is the extreme vibe environment. Rockets shake around a lot, and there are very precise components on the engine, like valves and turbomachinery, that need to work in that very high vibration environment. The qual test campaign is really just the last step of a many-year-long relay race that every team at Relativity has participated in. The qual campaign went well because the designers designed an engine that worked, because the technicians built the engine to a very high quality standard, because the test engineers worked through years of development campaigns to get that engine functional and reliable.
One of the big challenges of the Aeon R engine, especially relative to Aeon 1, the first Terran 1 mission vehicle engine, is that it's a throttleable engine. That means instead of on and off binary, the engine operates well over 40% of a throttle range. So that means it operates from 60% throttle to 100% throttle. And with that, closing on the run box and engine trim is quite difficult. As you change pump inlet conditions and interface pressures, and you also change power level, there's a lot of variables changing at once. So in dev, fully proving out what the safe hardware conditions are is pretty difficult. And in qualification, completing and closing on that run box is really, really incredible.
So we wrote automation here in-house during the qual campaign to demonstrate the flight-like pressures and timings of propellant that we will likely see on the stage. And we deployed that code and tried it out, and it worked the very first time.
Now that the stage 1 engine is qualified, we're proceeding into stage 2 engine development, which is where we will learn how to operate the differences in the stage 2 engine compared to the stage 1 engine. We're also getting into stage 1 flight acceptance testing. So the production line is up and running. We'll be acceptance testing those engines that come off the production line. And I'm actually really excited about this. This transition is one of my favorite parts of any engine development program, where you go from developing the engine, figuring out how to operate it, to really smoothing out the process of building and testing engines. In addition to everything that's going on in the engine program, the engine is going to be mounted to a vehicle, and we're going to do a vehicle operations campaign. Stage test and launch, I think, are some of the coolest operations that the engine gets to do. So I'm really excited to scale up to vehicle operations and learn how to operate the vehicle as a whole Relativity team.
That's a whole new suite of hardware, lots of new ConOps and automation that we have to write, and new technical challenges that I'm excited to see our team take on.
We've got to qualify a stage 2 engine. We've got to acceptance test 13 stage 1 engines. And then we have to do all that at a stage level. So it's exciting, but it's like the start of an excitement that will continue on for another year.